Viking Products Group, today representing Viking GmbH. Together with me, there's Mr. Ali Kudu, who you know, our sales leader in the Middle East and North Africa region, right? And there's also going to come afterwards our colleague Kamal Abdelhadi. So there's going to be 3 presentations, let's say, one for the ULI, another one will be for standard fluids SF1230, a new extinguishing agent that we have in the market, and then a short presentation of about 15 to 20 minutes to introduce you to other products that we have in Viking, like water, detection. That's just going to be a brief overview, so you know what else is in the menu, okay? Any questions so far or any comment? Ready? Right. So, this is going to take around 1 hour, 15 minutes approximately, maybe shorter, maybe longer, as per what you need, right? There's going to be time allocated, especially at the end of the presentation, for questions and answers. But as I said, if you have any question, please feel free to stop me, right? I understand that you are a busy businessman, right, and you may need to have a phone call whatsoever. I do understand, right? My recommendation is please try to limit as much as you can the phone calls so you can make the best of the presentation, right? Right on? So there's a long list of things that we're going to cover, starting with, that's one slide each, so don't freak out, don't worry, right? So that's the agenda today. General justification, why did we come up with this product? Why is it necessary? Something new in the market, right? How do we operate? So how does it work? And then in production, what happens in production, right? Before our end users receive it, right? So you also understand what happens. So let me start with section 1, general, right? So fire extinguishing systems maintenance in power infrastructure in the Kingdom of Saudi Arabia, right? Why would you even need liquid level indication, right? In reality, it's content monitoring. So why would you care about the contents of extinguishing agent in your cylinders? Let me make an obvious question. Is everybody familiar with fire protection equipment, with fire suppression systems? Yeah. Right. So we know that they are...
Sorry, guys, just if we can, let's say, arrange like each one on them. So when we take photo, because like we are spread everywhere, if that's possible, if you don't mind.
No.
Yeah. Sorry for that. Like to split. We keep the spacing, the social distancing. It's a big place, so let's use it. Let's use it all. Yeah? Okay. Thank you guys. Please.
Thank you. So,
now I'll come to sit next to my friend.
okay. So, why would we need to check contents, right? In these systems, we know they are very safe, they are very tight, right? Because there's a number of risks, right, associated to any fire protection, Viking or anyone else, like dust, sand, soil contamination, for example, if you're close to the shore, like in Jeddah, like in Tamam, that can, over time, if they are exposed to harsh environments, that can one day induce to leaks, right? Extreme temperatures, right? If there's sharp fluctuations or even very high temperatures, that can maybe at some point damage the seals over time. Another risk is because we have to comply with strict requirements, right? Why is that a risk? Because if you do not comply, right, if your contents are not enough, it's not just a risk of safety, it's also a risk that there may be an audit and they say, hey, this is not safe, right? Non-conforming. So it's a risk as well. Because you may be in a remote, dispersed location, right? And it may be difficult to go there regularly, let's say, and check out the contents by the pressure gauge. And because of the high criticality of assets. Imagine there's a leakage, right? And you lose significant amount of agent, there's a fire, the system goes off, but it just doesn't put out the fire, and you gentlemen are operating with highly critical infrastructure, right? Power generation. Imagine what can happen in case one of these systems goes down, right? It can be a hospital that runs out of power. It can be a whole neighborhood, right? But we know there's certainly a high risk associated that can impact your end users, your customers, right? So why, in a nutshell, why do we need agent content monitoring? Why is it crucial, right? I have extracted on the right-hand side the Saudi building code, the fire code, actually the 801, where you can clearly see that containers, the extinguishing agent quantity needs to be monitored regularly. And there's a limit to how much agent you can leak until you need servicing. So as far as I'm concerned, this is of mandatory compliance in Saudi Arabia. The NFPA 2001 has a number of clauses that I have extracted that likewise, they say you may use a liquid level indicator, right? You need to do semi-annual service and inspection. There's a maximum of 5% leakage that you may allow, right? The device has to be listed, that's why the ULLA is FM approved, and the information needs to be recorded over time. And this is actually a requirement both of NFPA and recorded according to SBC. So you need to take record of what is the content of agent over time, right? So this is the code. So why is it crucial? Number one, early leak detection, right? If I measure the content and I see that today this is the amount of agent, I come over 1 month and I see, it seems like there's 100 grams less. And I go over time, it seems like there's 100 less grams, right? I predict that it seems like there's a leakage going on. So you can predict that earlier, whereas with a contact pressure gauge, you can only read the pressure, but you cannot acknowledge, right? Second is because it assures system readiness. So correct fill means correct discharge time and correct design concentration. This is obvious, right? Because it reduces maintenance costs, right? If you can anticipate when this is going to happen, right? You can, if unfortunately you have a cylinder that's leaking, you can decommission and you can service before you have lost, number one, too much agent, but number two, and this is very important, right? Because if you can anticipate when this is going to happen, you don't have to come as an emergency to your site. You can plan accordingly. You don't have to disrupt the business operation, right? As opposed to imagine, oh, there's a cylinder leaking, now what do? Now I have to warn everybody, today we cannot work because I have to decommission the system. Oof, that's a big problem. Now if you can warn people, hey, I have a leakage, today the system is operational, but in 2-3 days, whatever has to happen in this particular substation needs to stop. Then everybody can plan, and then you can do that without disrupting your business, right? Fourth is supports predictive maintenance, and number 5, compliance evidence. I'm pulling it out there that we have to show that we have our record of the agent over time. So this is just an example. Let's imagine we have a power substation from Saudi Electricity Company. I extracted this one, honestly, right from Google. I have a data sheet, right? Let's imagine a 36 kilovolts, right? That can be in a 10 cubic meter, well, that would be a 10 cubic meter asset. Let's imagine it's in a room of 100 cubic meters, and that's where you have your power substation. So we talk about a fire class C, because it's energized equipment that can operate from 0 to 50 degrees. 0, I would say it's unlikely in Saudi Arabia. Correct me if I'm wrong. 50 seems to be a little bit more likely, right? So that's the volume, that's the voltage. So normal protection conditions, our system is working normally. So NFPA 2001 requires a minimum design concentration of 6.1 because it's a high hazard energized asset. So the minimum design quantity I calculated would be 97.9. The minimum extinguishing concentration is 4.5. That means I discharge and I reach 6.1. After 10 minutes, right? The concentration should not be below 4.5 at the heights of the asset, approximately 2.2 meters. That is the home time, right? So this is how we design the systems. Now imagine, this is where we start. Imagine there's a leakage, right? And then over time we go here, right? A leakage of 27 grams per day, that's nothing, right? That's a very minor leakage. But because it happens per day, after 6 months, that would be already 5% leakage, right? In a cylinder with 97.6. That means a very small leakage within the semi-annual servicing time may mean that if you do not pay attention to that leakage, if you just do that semi-annually, when you go there, it's already non-compliant. That's why it's important to predict. So number one problem is it's non-compliant. That by itself is a big problem. But on top of that, there's safety. So what happens is that instead of a 10 minutes hold time, that will reduce to 8.5, right? And you would say, okay, Adrian, it's 1.5 minutes if fire brigade has to come in whatsoever, that doesn't make much of a difference. It does, why? Because number one is below the minimum allowed, no compliance, but second, because of the risk of reignition. These 10 minutes are not designed to give time to the fire brigade to come, right? The 10 minutes hold time are scientifically proven to be enough to prevent reignition. So that's the big risk of such a small leakage. That's why you have to take a lot of care. That's why, as I see, as you can read up there, why agent content monitoring crucial, right? This proves why, okay? So, now everybody understands why content monitoring is so necessary, what are the problems, the real problems that it can bring to you, right? So we came up with a solution, the ultrasonic liquid level indicator. And you may think, well, Adrian, there's already content monitoring devices out there. There's the mechanical liquid level indicator, we have the contacted pressure gauge, there's mechanical weighing devices. So if there's technology, why do you come up with a new one? So this is what we're going to discover. Why do we need something else? Why did we in Viking think it's not enough, right? Weighing devices, they can be very heavy, they are not necessarily that much accurate. 5% they can achieve, not 2.5 rarely, right? Transportation is more expensive, installation is more complex, there's much more steel. Compare mechanical, one cylinder mechanical weighing device would be maybe 3 times more heavy than this, right? But this is for all of installation, whereas the mechanical weighing device would be for each one. So we came up with something that's compact and simple. One single device can be used in multiple installations. You can have one in each substation, or you can even have that unit and walk around multiple sites. Second is because it's easy to use, right? There's 3 knobs. In the manual it tells you, okay, if you're going to measure this cylinder, this agent, then you just put this, this, and that. You don't have to figure it out, you just have to read the manual. Then all it does is you put it underneath the level, an LED light lights up. You put it above the level, it goes off. It's very simple to utilize. So we needed something that was simple, as compared to other devices which are not that simple necessarily. Because it's truly unique and approved, and now this is already gone, now it's completely approved, right? And design and performance, more than 6 hours of autonomy, even though that can last for much longer because you typically switch it on, use it, and switch it off. So that will be 6 hours of duty. Can be used many, many, many times. Right on? So a quick comparison between the mechanical liquid level indicator and the ultrasonic liquid level indicator. So what are the pros and cons? So mechanical liquid level indicator, construction. The mechanical is only suitable for welded cylinders, right? Why? Because it requires the sport. The sport has to be welded, and if the cylinder is welded, it cannot work at more than 25 bar. 42 is already too much for a welded cylinder. As opposed to the ultrasonic liquid level indicator, that works with seamless and welded, right? So therefore you can work with 42, 50 bar systems with no problem. Second advantage is mechanical liquid level indicator, the reliability. If you are familiar with how they work, the operation is you have to unplug this plug, you have to lift up the tape, right? And then go down again, and you have to feel when it reaches the level, right? And you have to do that a couple of times. So it depends on your sensitivity. And that can be different from one person to another. So you may try and say, this is the level. And another one comes in and says, no, I believe it's here, right? And therefore it's unreliable. With the liquid level indicator, if I put it here and the light lights up, there's no doubt. Anybody would see it's on, right? The light is on. So third is operation. It's a lengthy process, whereas with the liquid level indicator, some of you have already witnessed that. We're going to show a video. It's a very quick exercise. Safety. Every additional port is an additional point of failure or leakage, right? So with seamless containers, we minimize the risk of leakage. And third, or fifth, very important, business continuity. Before I made a hint about that. But imagine there's a malfunction in this device, right, in the liquid level indicator. That means the whole cylinder needs to be decommissioned for repair. That means the whole installation is decommissioned for repair. that means the power substation where which this is protecting is unprotected, right? So one single device of this failing, if somebody breaks it, for example, means the whole power substation needs to stop or needs to go unprotected for some time. So with the ULLI, imagine somebody drops it, somebody kicks it, right? It fails, because it can happen, right? Imagine it fails, your system remains operational. All you have to do is get your ULLI, ship it for repair, and bring it back. And maybe you can have even a spare unit. So your installation remains constantly operational, okay? There was one question, by the way, that I can remember from, please sir.
There are more than 35 or 40 bar. This welding or not?
So this works with welded and seamless cylinders, right? Welded are 25, seamless as well, up to 50 bar. So there was a question about the calibration certificate that I can remember, whether, now I'm talking about servicing, repairing, right? Whether we could do that in, let's say, regionally, right? Or we have to ship it back to the UK. Discuss with my manufacturer, right? My partner, we can do that regionally, right? There's a partner that could do that for us. So that's something that's simplified. Because I remember you particularly made that question, and I took good note of that. We addressed that.
Right. So we have the ovation of destination.
Yes, yes, right. In the beginning, it would be in Dubai, truth be told, but we are exploring the possibility of bringing servicing here as well for calibration in the Kingdom of Saudi Arabia. Right. Okay, so how does it work, right? I'm gonna take the opportunity to pass it by. If you just would like to explore it a little bit, if you would like to check it out and then pass it to the next, to our next speaker. So how does it work? There's a number of components. There's a sensor, right, that operates both as an emitter and as a receiver, right? This is this small piece here, handheld, that emits and receives the signal. It works with ultrasound, right? That's the signal that it emits, right? That travels through the walls of the cylinder, through the liquid, right? Reaches the siphon tube and then bounces back. So depending on the time elapsed from the emission of the signal until it comes back, it can decide or it can identify if there's agent and what agent is there. That's how it operates. So the signal echoes multiple times, and this device has the ability to recognize if there is liquid and what liquid is there. So the settings, based on we have to adjust them based on the type of cylinder and based on the agent that's inside. And after that, how it works is it's not just the device that's part of the technology, right? Because the device tells you level, okay, so the liquid is here, right? But what we care about is agent contents.
Cylinder have sensor and the same signal by Wi-Fi?
No, it's local. So this device that is handheld, right? I'm going to show you a video shortly so you will see that. But it's handheld, so you put the sensor and then a light will get on. So when it is above the level, when there's gas, the light will go off. So when you move it, then you can identify where the liquid is. And you can see that in your hand. Does that make sense?
Looks like the solar system,
Yes,
exactly, typically the same, but this one is to check the agents.
To see there's a baby inside the cylinder.
There is mentioned frequency. For frequency is mentioned on the controller. Okay. So how we know what frequency we have to use? Because there is mentioned one.
It's in the manual. So you have your cylinder,
Yeah.
right? You have your part number, and you have your agent. It's either HFC227 or FK. You go to the manual. It will tell you this knob you put it in place A. This knob you put it in 100. This knob you put it there.
So as per agent we have to step you.
Exactly.
And what about game?
What about?
Game. There is mentioned also game.
The game is also defined in the manual. You have to just follow the manual.
Just for we have to follow.
The manual will say put it in 100. You put it 100. That's it. You don't have to figure out the settings. You just have to read them from the manual.
Yeah.
Okay.
That's fine.
Right on. So when we have the level, what matters is the agent amount. So when you go to the manual, there's conversion tables that will tell you if you have this cylinder with this pressure and at that temperature particularly, this is the level, so this is the number of kilograms, right? There's there's something relevant to that, which is that the conversion, there's a number of factors that influence that, right? And that's a critical, say, factor that decides the accuracy, right? There's pressure, there's the volume inside, there's the type of agent, there's a solubility of nitrogen, the heavy slow, there's a lot of thermodynamics inside, right? So it's not enough knowing the level, you need to know what is the agent content, and that you can find that in the manual. Though we will see there's a quick content verification method. Right, what is in the kit? We acquire a liquid level indicator kit. What's in it for us? So it comes with, of course, the main device that everybody is right now seeing. It comes with a rugged case, right? That case is prepared to go on field and operate the device. It comes with your manual, right? It comes with your calibration certificate, which is unique for that particular device. And it comes with 2 samples of Kaplan gel, 2 sensors, one general and another spare in case there's a breakage, and the BNC connection cable. Okay. We have, of course, spares available of all of it, except for the calibration certificate, which is unique, and we can
Every year we have to do the calibration, or there is limitation?
It comes calibrated by default. We had also that conversation, how often do we have to calibrate that? Our recommendation is every year, right? And we Viking, we do the calibration for you. Every year you send that back, we calibrate it, ship that back to you. Okay? So what else is in there? These labels that we're going to see how we utilize them, right? So this comes together with a cylinder, and these are attached to the cylinder. Now we're going to see exactly how. So there is basically, this one is placed where the level is at the factory, right? The technician in the factory will define where the level is, and this is just a ruler to help you so you don't have to come with measuring tape, because you need the level, so you don't have to bring the measuring tape. All you have to do is read it here, right? So this is for support. So this is let's say a brief description of everything that's in the device. There's a BNC connector for the oscilloscope that we do not need to use as end users, and for the sensor, the ultrasound sensor. There's frequency, gain, and hold off time. These settings, you just have to read them in the manual. There's an on-off toggle switch. There's a low battery indicator, LED light, in case it runs out of battery, right? And that's it. So technical specifications, where does this work? Does it work with every cylinder, every field ratio? No, honestly no. It works in what we believe it's a broad enough range, right? Which is from 0 to 50 degrees Celsius. It could be that I don't expect temperature to go below that in Saudi. Can it go above? Yes, I recognize that maybe in Saudi you can have more than 50 degrees Celsius, right? Maybe in the power substation. I will make a note around that. Cylinder range 80 and 180, right? It's true that there may be smaller cylinders, but we know that this device operates correctly in this particular range. With those gases, at this fitting range, right? That's broad enough, with that accuracy of plus minus 2.5%. Why am I stressing what we can and cannot do, right? See, it would be very easy for me to just say, put it this way, every manufacturer is happy to tell you what they can do, right? But I believe you rather trust the manufacturers who actually are honest and say, and this is what I cannot do, I'm not gonna bluff you, right? So when we were testing this, we recognized for smaller cylinders, right? If they are that round, the sensor doesn't make proper contact, not with this sensor, right? Because we do not have a different kind of sensor, we prefer to not sell that to our customers. So I want to be honest, I'm making sure that my product is working perfectly, right? And you're not gonna get surprises. Likewise, with very low field ratios, it would not operate properly. So this is an act of honesty from Viking, let's say. In this range, it will operate perfectly fine. Right on, that would be the general introduction. Now I'm going to navigate into how to operate that, right? And how to use that on field. Before I do that, is there any question, any comment that anybody would like to make?
What's the lifetime for
The sensor?
Yes. What's the lifetime?
No, there's no lifetime for the sensor. It's a ceramic sensor. Unless you crack it, there's no you, as I was explaining to you. Right, also operation, right? This is the manual, right? That you got that has design and function that you have already seen, how to operate, troubleshooting if you face some problems. It also gives you some indication of what could be going wrong before you need to call your technical service, spare parts and accessories, how to dispose, technical data, right? So these devices only for authorized Viking distributors and qualified specialists. So we can give training and we can do hands-on training for people to duly operate that for those brands in compliance with those systems manuals. What is the bottom line here? That this device works with a fire suppression system, right? So unless you have a VSN 230, VSN 200 system that you have designed, installed, and maintained, this device by itself means nothing. It's a complement to a fire protection equipment, right? That's the bottom line.
You can use this device with the MX 200 system.
From a technical or from a political standpoint, technically yes, right? But the approval is only on Viking. On Viking, right? So how does it work step by step in a nutshell, right? So the first thing you have to do is the initial setup with your device, right? You set up hold of time, frequency, and gain, these three knobs. The manual tells you exactly based on your cylinder and your agent what settings you have to put. The next thing you do is you have to clean the surface, right, where there's the labels. Then you apply a gentle amount of ultrasound gel. I'm going to show a video shortly so you see what it is, right? You apply a stripe, let's say, of Kaplan gel. You attach the device to the cylinder and switch it on. And then you initiate the reading, right? I'm going to show, a video will be much more explanatory, right? You find the level, you measure with the level, the sticker measuring tape that you have on your side, and then you confirm the weight using the manual. If this is the level that I found, my cylinder is 926, my pressure is 50 bar system, I go to the manual, read the table, I'm going to show shortly how, and then you know what's the contents, right? This is what a cylinder would look like, right? So you got the level sticker. That means the technician in the factory, when he was making the reading, right, it identified that at this temperature, 21 degrees, the level was here, right? And this is the one that's critical. This label is showing the distance between the bottom of the label to the floor, right, 180, and it's giving you the range from 0 to 50. Where should you expect the range? Why? Because the level is not constant. When there's variations of temperature, the level also moves and can move significantly, right? So the level itself doesn't tell you anything unless you have this information. Right, and so how do we operate, right? Yeah, I'm gonna show a video later on. So first thing we have to do is, number one, clean the space in between the two labels, right? Because debris, dirt, dust whatsoever may impair the reading. So we clean it, water works, household cleaning works, nothing aggressive. Then you measure the cylinder temperature on the surface with, for example, a thermal gun, right? So you write down these temperatures. Then you apply gentle, the manual says thick, I prefer to say a gentle layer of the ultrasonic Kaplan gels in a vertical stripe, right? So all over in between. And then you're going to measure the sensor. You put it underneath this sticker, it should light up. Then you put it above the range, it should light off. You confirm that's where it is, right? And then you start moving around. I will explain how exactly. Right? So you measure the temperature, you identify your system, if it's a VSN 230 or a VSN 200, you identify your cylinder type, you have your part number in the container label, you can see if it's a 888 or a 926. You know what's your working pressure, 25, 42, or 50. That's a system pressure. We don't need to read it in the pressure gauge, right? Then you find, as described, your predicted level, and then using this information that I just mentioned, and this table, right? So if I have this here, you have field quantity, right? You have temperature, and you have level, right? For this particular cylinder and that particular agent. So this is a 888 cylinder, VSN 200, with cylinders AAA, right? So I know my cylinder, I measure the temperature, and I got 430 millimeters at 20 degrees Celsius. Then I go here, I know I have 64.5 kg, simple as that, okay? This we described before. Right on, so what is the, let's say the strict way to measure that? So you have your label, right? You know what's your expected level and what is your plus minus 2.5% range. So you know that you have to move all around this range, okay? So you first off, place it down here, then the light should switch on. You put it up here, then it should switch off, right? Because this is plus minus 2.5%, as long as you move in within, that means you already covered you are within the tolerance. Now, if you want to fine tune, what you would do is the sensor, you would go up, then down, and then start moving up in little steps until the LED light switches off. So when it's on, it's on, it's on. Next time it's off, okay, here's my level. That's when you need to do that accurately. So that was my predicted level. That is my range. This is where I found my level. I know it's already fine. Now, if I want to know by the gram exactly how many kgs do I have, then you do the full procedure. You go up step by step until you find the exact level. Then you go to the manual. Now, if you don't want to know exactly how many kgs, you just want to know that you are within the range, you put it here, it's on. You put it there, it's off. Then you know you're good. Okay? That's how it goes. Then we got a little bit of troubleshooting. Before we go through that, I'm going to show a video because I know that orally it's difficult to describe. Nothing can be clearer than an image. So bear with me just 1 second.
Now I will start to do some steps up. Step on. Step on. Step on. Step on. Now, step on. It is off now, which shows the end of the liquid level inside the cylinder. As you can see here, the sensor, the middle of the sensor is the liquid level. So, as you can see here, the sensor position was almost the same spot of this sticker, which shows that there's no leakage or gas has been vented out from the cylinder valve or any leakage before. This is a thank you for watching.
Very good. In all honesty, we were. Please go ahead.
As we know that we need to know some exact point to know the level of the achieved there. But as your device has some cross section there, it's not the point.
Mhm.
It has a cross section. So how we will be sure that this is the point? Are you getting my question?
Yes, center line.
Yes.
That's where you make the reading.
Center line.
Center line. Can be, it could have been 12, it could have been above, right? Because what matters is the agent content. And this is just a reference, right? In reality, I do not know if the level is exactly here, exactly here, exactly here. What I know is that when I use this as a reference and I use a table, the agent is exact. So FM is not asking me to prove that the level is exact. It's asking me to prove that the weight is exact. So with this reference,